states the ratio between the number of moles of solute and volume of solution. Okay, and make sure it is a big M, and that does matter because molality, ooh, she's thick. Molality is a small m. So we're doing big M right now. So for our first example, we're going to find the molarity of a 500 ml solution, which contains 60 grams of NaOH. So up here, I just want to see, first of all, NaOH dissolved. That means it's a solute if it's being dissolved. If we look up here, it says moles of solute, not grams. So we definitely know we're going to need to do a conversion of grams to moles. And then we're also going to go from milliliters to liters because it is in liters of solution that we need. So of course, to go from grams to moles, we just use our conversion where 1 mole of a compound, so NaOH, is equal to the molar mass. Sodium has a molar mass of 23, oxygen has a molar mass of 16, and hydrogen has a atomic mass of 1. So all those 3 atomic masses added up together equal 40, and that is the molar mass for this compound. And just like we've done before, everything on top gets multiplied, everything on the bottom gets divided. So we're going to do 60 divided by 40, which gives us 1.5 moles of NaOH. For our solution, we need to go from milliliters to liters. The easiest way to do that is you're just going to go to Google and do ml to L. You just type in how many milliliters you have, and it shoots out how many liters you have. So I don't expect you to just remember that conversion. Just do that for now. So we have 0.5 liters of solution. Now we can put that into our equation, our 1.5 moles of sodium hydroxide over the 0.5 liters of solution, and that gives us 3 moles per liter, or 3 molar. You can do either one in problems like this one right here. This would be 1.5 molar, okay? So calculate the mass of solute required to prepare 1 liter of a 1.5 molar magnesium chloride solution. So first things first, we're just going to jump into some algebra. What we want to do is we want to isolate our unknown, which means we want to have all our knowns on one side of the equation and our unknown on the other. So to do this, we're just going to multiply both sides by liters of solution, and this side cancels out. So now we have molarity times liters of solution is equal to the moles of solute. So we just plug in our numbers. 1.5 is our molarity times 1 liter of solution gives us 1.5 moles of magnesium chloride. But we're not done. We're asking you, how would you prepare it? If I had you guys in class and I asked you to start a lab and I said, hey, go get 1.5 moles of magnesium chloride, you'd be like, what? How do I measure that? Instead, in an actual lab, you would measure by grams. So when it's asking you about preparing a solute, you need to go all the way to grams because that's how we measure things out before we add them to our solution. And just like we did right here, we're just going to use the molar mass of sodium hydroxide times the how many moles we have of that compound, and that gives us 142.5 grams. And now we can move on to dilutions. Dilutions are my favorite. They're pretty easy. It's just M1 times V1 equals M2 times V2. So this is a big M, which means this is the molarity of our first solution times the volume of our first solution is equal to the molarity of our second solution times volume of our second solution. So here's an example. What volume of 12 molar potassium chloride is needed to prepare 5 liters of 1.5 molars potassium chloride solution? So we have 3 given, so we are looking for volume in our solution 1. So I always start by writing out this equation, and then I just put what we're given right above. So I'm given 12 molar for my solution number 1. I don't know my volume, so I just put V. 1.5 molar and 5 liters for our solution 2. So again, we have to isolate our unknown. So we just divide both sides by this 12 molar. And then these 12 molars will cancel out, leaving this volume by itself, which gives us 1.5 times 5, divided by 12 is equal to our unknown, which is volume 1, and that would be 0.625 liters. So here's another one. Find the volume of 2 molar sodium hydroxide stock needed to prepare 500 mils of 0.3 molar sodium hydroxide solution. So I'm given my M1, M2, and V2. I'm looking again for V1. So I'm going to manipulate that equation so that V1 is by itself on this side, and then I just plug it in. 0.3 times 500 divided by 2. So my V1 is equal to 75 milliliters. Your unknown needs to be in the same units as your known sample, okay? So my volume 2, which is my known, is milliliters, so my unknown has to be in milliliters as well. Now let's talk about molality. This is the lowercase m. It's the ratio of moles of solute, just like the molarity, but on the bottom, instead of liters of solution, we have mass of solvent. Remember that a solution has two parts, the solute and the solvent. So this one, we're directly comparing the moles of solute to mass of solvent. Find the molality of a solution made by adding 4.5 grams of sodium chloride to 100 grams of water. So my solvent is my water. Remember, this is just salt water. Think about when you make salt water, what is being dissolved and what is dissolving. So our water is dissolving the salt. I like to remember that water solves everything. It's a solvent. And then so our solute would be that 4.5 grams of the sodium chloride. And if we look at our equation, we don't want grams. So again, we have to do our conversion right here. I'm just going to type this out. Maybe I won't. So we're going to go to our periodic table, and we need to find the molar mass of sodium chloride. So sodium has an atomic mass of 23. Chlorine has an atomic mass of 35.45. So our molar mass is those two atomic masses added together, which is 58.5. Oops, I did that the wrong way. It should be in the bottom. So we have 58.5 grams is equal to 1 mole. And we're going to do 4.5 divided by 58.5, and that gets us 0.077 moles. So now we have our moles of solute, and we just need to convert this 100 grams to kilograms. Again, you can just use Google, and it would be 0.1 kilograms. So I plug that into my equation, 0.077 divided by 0.1, and that gives me 0.77 moles per kilograms. This last part, it's really funny. It says it's a summary. We didn't talk about any of this. We just talked about this. So don't worry about this for now. We haven't learned about it. But we learned about molarity, molality, and dilutions. So now let me talk about your worksheet for a second. So what I always do is, like I said, I just write the equation out for dilutions. So M1 times V1 equals M2 times V2. This is worded a little weird. What you don't need to worry about is you don't need to worry about this number. That number is not going to be in this equation. What is going to be in this equation is the 2 molar, the 50 mils, and then we're trying to get half of the original molarity. So this is our original molarity. So M1 is equal to 2 molar. V1 is our unknown. M2, it says it's going to be half of our original molarity. So half of 2 is 1. And then our volume is going to be 50 milliliters. The volume for every single one of these equations right here, A, B, and C, is going to be 50 milliliters. So now you just plug these 3 numbers into this equation to find V1. remember the way we isolate this is just by doing this. That would be the equation we'd use for these three problems.